Okay, so comprehensive review of chapter 5. It's been kind of nice because I can use the same review with Math 8, but you guys go into much more detail in your problems. I should say a lot harder type problems. So we're talking about linear relationships in this chapter, and we're talking about calculating slope, finding y minus y over x minus x, or the difference in the y's and the difference in the x, or when we're looking at a graph, the rise and the run. So I think by now everyone can figure out the slope. I'm not going to go through that. When we have a line, we have at least one intercept. So if we have a vertical line, we have an x-intercept. If we have a horizontal line, we have a y-intercept. But if we have something that has a slope other than 0 or undefined, we have both an x and a y intercepts. So looking at this graph, we can get our intercepts off the graph, and we can get our intercepts from an equation. So this one would say that we have a y-intercept of 2 and an x-intercept of -3. If I plug 0 in here for the x, I get 3y equals 6, divide by 3, y equals 2. If I plug 0 in for the y, I get -2x equals 6, x equals -3. So I looked at them off of a graph, and I proved it from the equation that those were the intercepts. One other thing that I didn't include in these notes that I need to for you guys is the direct proportional problems. If you have a constant rate of change and you have a line and it goes through 0, 0, it is also a direct variation. And we're only going to look at the form y equals mx because it has a y-intercept of 0. So when you look at direct variations, think of this form without the y-intercept there. So if we want to create equations of the lines, we have two forms that we can do that with. The first form is the slope-intercept, y equals mx plus b, or the point slope form, y minus y equals m times x minus x. In the slope-intercept form, we're replacing m and b. In the point slope form, we're replacing x, y, and m. So I have three equations that I'm going to work through, the three different situations that we have. Given a slope and a y-intercept, create the equation of line. Replace the slope, replace the y-intercept. It's that simple when you have a slope and a y-intercept. When you have a slope and a point, it's y minus your y-coordinate, which is 2, equals 3 times x minus your x-coordinate, which is -1. So I'm replacing the x and the y and the m, and then because I have this double negative, I'm going to change it into a +1. You may go right to the +1. You don't have to put the double negative in there. You can go right to the +1. So a point and a slope, you're just replacing. You're not doing any work other than taking those equations and replacing them. Then, if you're given 2 points, the first thing you have to do is calculate the slope. Notice in both of these, we had to know the slope. Same thing in this one, we have to know the slope in order to do that. So we take our difference in our y's over our difference in our x's, and we get -5 over 7. So once we have our slope, we get to pick one of our lines or one of our points. I'm going to pick the first one, so y plus 1 equals -5/7 times x minus 2. Unless they ask you for specific forms, you leave your answer right there. if they say they want it in both point slope and y-intercept, I'm going to go back to this one because it's easier. We don't have the fractions. I'm going to distribute out the 3, add the 2 to both sides, and now I have it in slope-intercept form. We can also graph these lines given their conditions. I'm going to write their conditions down again. 3/2 is a slope, y-intercept of -5. Slope of 3 goes to the point -1, 2, and 2, -1, -5, 4. So on our graph, we graph out the y-intercept of -5, 1, 2, 3, 4, 5. From there, we go up 3 and over 2, and we put our line. -1, 2 is right there. A slope of 3, up 3 over 1. There's our line. And this one, you're just plotting those 2 individual points, 2, -1, -5, 4, and drawing the line. Any questions so far? Okay. One other type of problem, and that goes back to that direct variation. Hold on, I went too far. Other thing in this chapter, parallel lines have slopes that are the same. Perpendicular lines have slopes that are opposite reciprocals. And we can use the information of knowing that we have perpendicular or parallel lines to get the slopes. And then they would normally give us a point that they'd want the new equation of the line go through. So just a different way of getting the slopes rather than calculating them is getting the slopes from the equations. The last thing we talked about in this graph is we talked about comparing 2 graphs. So if I graph the line y equals x plus 3 and the line y equals -x plus 3, you would talk about those 2 lines as having opposite slopes, opposite reciprocal slopes. So those lines are perpendicular to each other. They have the same y-intercept. So when you're comparing, you're just talking about the relationship between the lines. So if I talk about these lines, you would say they have the same slope, so they're parallel lines. One intersects the y-axis at 2, and the other one intersects the y-axis at -3. So it's a vertical shift of 5 units between the lines. Okay, the other type of equations that you would end up with, or the other type of things, y varies directly as x. If you're given that equation or those words, you're going to make equal proportions. So if y equals 9 when x equals 2, find y when x equals 6. So we always put the y's on top. 9 over 2 equals y over 6. What do you have to multiply 2 by to get to 6? That's 3. So 9 times 3, y would equal 27. Or you could go through the cross multiplications. 54 equals 2y. Divide by 2, y equals 27 that way. So those are the things that you're going to see on the test. Those are the things that you're going to need to do. Questions?